you're very, very, very busy, and it's very high pressure because, of course, there's no do-overs. You only get one opportunity to get all these instruments trained on the right spot.
On August 12th, 2026, the moon's shadow will cross the Earth. Along a narrow path, daylight will briefly disappear. Millions of people will watch a total solar eclipse. But one of the best views will not come from the ground. It will come from 50,000 feet above Earth. NASA will send a WB-57 research aircraft into the moon's shadow. The jet cannot outrun the shadow, but it can fly in the same direction. This will keep it inside totality for longer. Even a few extra seconds could be valuable. The eclipse path will begin in northern Russia. It will then cross Greenland and Iceland. The shadow will continue across the North Atlantic. Finally, it will reach Spain and part of Portugal. Much of Europe will experience a partial eclipse. Other regions will also see part of the sun covered. But complete darkness will occur only inside the path of totality. During totality, the moon fully covers the sun. The sky darkens, and temperatures may fall. Then, the sun's hidden outer atmosphere appears. It is called the solar corona. The corona surrounds the sun. It stretches millions of kilometers into space. Normally, the sun's bright surface hides it. A total eclipse blocks that intense light. This allows the faint corona to become visible. It creates a rare opportunity for scientists. But the opportunity lasts only a few minutes. The longest totality on the ground will be about 2 minutes and 18 seconds. In many places, it will be even shorter. Clouds could ruin the view completely. Earth's atmosphere can also reduce image quality. That is why NASA is taking the experiment into the sky. The WB-57 is a high-altitude research aircraft. It can carry specialized scientific instruments. During the eclipse, it will follow the moon's shadow. The jet will travel at about 460 miles per hour. At 50,000 feet, it will fly above most clouds. Weather on the ground will be less of a problem. Its speed will also extend the observation time. The cameras may remain in totality for nearly 3 minutes. That provides around 40 extra seconds. 40 seconds may sound insignificant, but the cameras can collect hundreds of extra images. The main instrument sits inside the aircraft's nose. It is known as the SAMI imaging system. The system contains 4 calibrated cameras.
On Eclipse Day, the WB-57 aircraft climbs more than 50,000 feet into the stratosphere. That's above most of Earth's atmosphere, where clouds, dust, and water vapor could obscure the view.
They will observe visible and infrared light. The cameras will record at least 20 images per second. In 3 minutes, they could capture thousands of observations. Scientists will study changes inside the corona. They will search for movement and escaping material. They will also observe solar prominences. These are huge structures of hot solar material. Some are larger than Earth. Different cameras will study them at different wavelengths. Each wavelength reveals different details. Infrared observations are especially important. Some infrared light cannot easily reach ground instruments. The aircraft will observe through less atmosphere. This could reveal details hidden from ground-based telescopes. One major mystery is the corona's temperature. The sun's visible surface is thousands of degrees hot, but the corona can reach nearly 1 million degrees. Scientists still do not fully understand why. The mission will also study material leaving the corona. This material becomes part of the solar wind. The solar wind moves throughout the solar system. It can affect satellites, communications, and astronauts. Studying the corona is not only about the sun, it also helps protect modern technology. NASA used the same imaging system during the 2024 eclipse. That mission captured useful visible and infrared images. It also revealed areas that needed improvement. Some bright features were overexposed. For 2026, the camera settings will be adjusted. Improved software will process the images faster. Every eclipse reveals a different solar corona. Solar activity and magnetic fields constantly reshape it. So, the 2026 observations will not simply repeat 2024. The aircraft is only one part of the mission. Student teams will also launch balloons from Iceland and Spain. In Iceland, teams plan to release 80 balloons. The launches will continue before and after the eclipse. Instruments will measure changes in the lower atmosphere. 6 more balloons in Spain will examine ozone and record images. Together, the aircraft and balloons will study the entire event. For most people, the eclipse will be a brief spectacle. For scientists, it will be a carefully timed global experiment. And above the clouds, NASA will chase the shadow for every possible second.